work a couple of exercises from the last review quiz that was due the 22nd. So first, properties of definite integrals. So a definite integral is one where we have bounds, and we learned that definite integrals relate to the area under a curve. So for example, if we have an integral of a certain function over a particular interval, as long as that function is a positive function, maybe it looks something like this. We learned that on the interval from a to b, this definite integral of the function represents the positive area under the curve between the curve and the x-axis. And then we expand on it from there. But there are certain properties that these integrals have that will allow us to work a problem like this one. It says, suppose that, I'm going to make this maybe a little bit bigger for the moment. Suppose that the integral from 6 to 7 of f of x dx is equal to 5. So you can imagine that what we're saying is that on the interval from 6 to 7, the area between the function and the curve is 5. However, that's only actually true if f of x is a positive function on that interval. If it's a negative or partially negative, it's going to be a net signed area, but don't worry about that. You can visualize it as an area. And so they want us to evaluate the definite integral written in different ways. So first of all, the variable that we use for the independent variable, it doesn't matter. So the integral from 6 to 7 is still going to be 5. Now, another rule that we are going to apply is that if you multiply a constant times an integral, it's the same as taking the constant inside. So in other words, this guy is the same as the square root of 3 times the integral from 6 to 7 of f of z dz. And again, this variable doesn't matter, so we're just going to have 5 times the square root of 3. Okay, so that's what would go here, 5 times the square root of 3. And then let's skip down to part D. So if we negate it, negating the function, it's the same as negating the definite integral. So this would be the same as the negative of the integral from 6 to 7 f of x dx. So that's just going to be negative 5. Okay. All right, next thing I wanted to look at was a problem from the same quiz where we're doing u substitution to evaluate an indefinite integral. Hold on one second. Okay, so in this case they are specifically telling us how to do it using a u substitution for u equals x squared plus 6. So the basic idea is that we want our integrals to fit one of our formulas for integrals, one of the types of integrations that we know how to do. For example, if we have the integral of x to the power n dx, then we know that we can integrate this by adding 1 to the exponent and dividing by that income value. So in other words, that would be x to the n plus 1 over n plus 1 plus c. So if we had x to a power over here, we would be in good shape, but we don't. So we're going to have to make a substitution that will allow it to basically force it to fit the pattern that we need, or one of the patterns that we can use. So oftentimes when we have a quantity being raised to a power, we will want to force it to fit an x to a power rule. Now again, the variable doesn't matter, so it could be u to the n du, and the same rule would apply. So what we're going to do is say let u be x squared plus 6, the quantity being raised to the power, and then we're going to make a substitution. Now when we do that, we also have to substitute for du, meaning the derivative of u, which is going to be derivative of, let me make this a little bit bigger. So if u is x squared plus 6, we're going to take the derivative and get 2x plus 0, or just 2x dx. And what we're hoping to see is that our u and our du are represented in the integral, and they are. And so you can see that the 2x dx will become our du, and then we're going to put u in for the x squared plus 6. So our new version of this integral is the integral of u to the negative 7th. This was our u here, and I've replaced it. And then 2x dx is going to be replaced with du. All right, so now it fits the pattern where we have the variable raised to a number, and oh, it looks like our output is kind of low. Hang in there, guys. And so we're going to apply the rule that we discussed a minute ago, add 1 to the exponent and divide by it. And so we're going to have u to the negative 7 plus 1. I like to leave negative exponents in our answers, so I'm going to flip this down to the denominator. We're going to have 1 over negative 6 times x squared plus 6 to the 6th power plus c. Okay, I'm going to grab another problem from our quiz and go over it. Now remember, the problem on your quiz might look slightly different, but it's going to be the same concept, just with different numbers. Okay, for this one we're going to find the area of a shaded region. And this is what that region looks like that we're supposed to find the area for. All right, so notice this is actually a piecewise defined function. It's equal to y equals x squared up until 2, and then it's equal to y equals 8 minus 2x between 2 and 4. Both of these functions are positive above the x-axis on the interval from 0 to 4. So when we say find the area of the shaded region, we can do this by using the definite integral. So we're going to evaluate a definite integral, but first we need to set it up. And since we have a piecewise defined function, we're going to have to set up two different definite integrals. So we're going to have the definite integral from 0 to 2, and for this one, the function that we're finding the area between the function and the x-axis is y equals x squared. And we're going to have our dx there. We're integrating with respect to x. And then we're going to add to that. That'll give us the area of, let's call it region A. And then we need to add to it the area of region B. Region B stretches from 2 to 4. And we're integrating the function 8 minus 2x dx. Okay. So we actually have two definite integrals to evaluate here to find this area. Okay, so for the to evaluate a definite integral means to find the antiderivative and then plug in the bounds and subtract. So let's do each one individually. The integral from 0 to 2 of x squared dx. The antiderivative is going to be based on the rule we just discussed, which is when you have x to a power, you integrate by adding 1 to the exponent and dividing by it. So we're going to have x cubed over 3. We don't need to write plus c when we're doing a definite integral that has bounds, because when you subtract, when you plug in and subtract, the c would cancel out anyway. So we're going to plug in our always the upper bound first. So we're going to have 2 cubed over 3 minus, and then we plug in the lower bound, 0 cubed over 3. So that's going to be 8/3. Now remember, that's just the area of region A. Let's go ahead and find region B now. 8, so remember the antiderivative or integral of the constant is just going to be the constant times the variable of integration. So that's going to be 8x, which makes sense because the derivative of 8x would be 8. And then we are going to integrate 2x. We can just leave that coefficient -2 and deal with the x. So we're going to have x squared, x is to the power of 1, so we're going to add 1 to it, and then divide by it. So x squared over 2. Okay, this is the antiderivative without the c, but remember we don't need that because we have bounds to plug in. So we're going to have 8x minus, the 2's cancel, that's an area of 4. Now, that is just region B. So if we want the total area, we found that region A had an area of 8/3. Region B had an area of 4. So look at that adds up to 8/3 plus 4 is the same as 8/3 plus 12/3, which is going to be 20/3. Okay, which is almost 7. It seems like that's a reasonable value. If you look here, the area on the interval from 0 to 4 would, if you went all the way up to 4 and filled in the whole rectangle, that would be 16. This looks like a little bit less than half of that, so it makes sense that it would be almost 7. So we get 20/3 for that one. Okay, I'm just going to check on, let's see, there's no questions, so I'm going to go ahead and do one more from that quiz. Okay, this one is just asking us to evaluate a definite integral. I'm going to grab it. Actually, let me just go ahead and add a page here. So evaluate a definite integral. We just evaluated a couple of definite integrals in the previous problem in order to find area. But this definite integral has a square root in it. So let's see how we deal with a square root. So if we're looking for the integral from 1 to 4 of 3x squared plus the square root of x dx. Now again, this probably represents an area under the curve. In fact, it definitely does because these are both positives. But we're not concerned about that. We just want to know what the numerical value of it is. So we need to, first of all, notice that we have two separate functions being added together. You can actually separate it, like you could actually write integral from 1 to 4 of 3x squared dx plus the integral from 1 to 4 of the square root of x dx. But I tend to just remember that I can integrate each part separately and I don't have to actually separate it out and not actually write it that way. So I just leave it the same. But one thing I do need to write, just so that I can visualize it better, is that we don't really have a rule for taking the integral of a square root, but what we do have a rule for is a power. So I'm going to write the square root of x as x to the 1/2 power. Okay, now both of these, each of these terms, we can apply the power rule. When there's a coefficient in front, we can just leave it the same. So we're going to have 3, and then adding 1 to the exponent and dividing it, we get x cubed over 3 plus, for x to the 1/2 power, we're going to add 1 to it and get 3/2. So x to the 3/2. But when you divide, it's going to flip that over. But we'll just write it as division at first. So x to the 3/2 over 3/2. And remember, we're going to evaluate this from 1 to 4, so I don't need to write the plus c part. Okay, so this is going to be, the 3's cancel out and we get x cubed. Flipping over the 3/2, we're going to multiply by 2/3, so we're going to have 2/3 x to the 3/2. And we're evaluating that from 1 to 4. So plug in your upper bound. Oops, that's supposed to be a plus, not a times. Plugging in your upper bound, you're going to have 4 cubed plus 2/3 times 4 to the 3/2 power. And let's see, 4 cubed is going to be 64. Oh, you know what? I want to write out the subtraction. Don't want to lead you to think we can forget about it. So we're going to take that sum with the 4 plugged in, and we're going to subtract from it whatever we get when we plug in the 1. So plugging in the 1 would be 1 cubed plus 2/3 to the times 1 to the 3/2. Okay, so going back to the first set of parentheses, 4 cubed is 64 plus, we're going to have 2/3 times 3/2 power means take the square root and then cube it. So the square root of 4 is 2, to the 3rd power is 8. Okay, so that's the first set of parentheses there. And then we're going to subtract from that 1 plus 2/3. Okay, so we have 64 plus 16/3 minus 1 plus 2/3 is 5/3. So we're going to subtract 5/3. So that's going to be 64 plus 11/3. And what would that be? It's going to be 203/3. Okay. And we're just going to leave our answer as an improper fraction. Okay, I'm just going to check to see how our streaming's holding up here. It looks good. Okay, we're going to do one more problem. Gonna grab a screenshot of it real quick. Okay, so this is going to be an integration that involves substitution and trig functions. All right, so it says evaluate the integral, and we have the integral of sine of 2t plus 3 over cosine squared of 2t plus 3. And we definitely do not have an integral that gives us specifically sine over cosine squared. There's a couple of different ways that you could go about this, but I'm going to stick with thinking of this as the sine of 2t plus 3 over cosine of 2t plus 3 squared dt. I rewrote it this way just to emphasize that we have a quantity being raised to a power. And again, very often when we do a substitution, we look for the thing being raised to the power, and we use that for our substitution. So I am going to try, and don't be afraid to try different substitutions. So maybe you try something, it doesn't really work, and you try something else. But I'm going to try the cosine of 2t plus 3 to be my u. And then I'm going to make a substitution, and I'm going to hope I get an integral that I can work with, that we have a formula for. But remember, when you do that substitution, you have to find du, and it will be equal to something involving dt. So du, the derivative of u, remember the derivative of a cosine is negative sine, but in this case we have the cosine of a quantity, so we're going to have to use a chain rule. It's going to be negative sine of 2t plus 3, that stays the same, but then you multiply by the derivative of the inside. So the derivative of 2t plus 3 is going to be 2, and we're going to have 2 dt. Oop. dt here. Okay, so looking back at our trig function integrand, we see the sine of 2t plus 3 and the dt, which, since that's in the numerator, that means that it's kind of on the same level as the dt. And so we have that and the dt, but we're missing the negative and the 2. Well, normally you cannot make a change to an integral, but since that's just a difference of a constant multiple, we can actually put negative 2 in here as a coefficient as long as we compensate, and on the outside we're going to divide by negative 2 or multiply by negative 1/2. So that way, because remember you can bring a constant in or out, so that way I'm only changing this integral really by a factor of 1, so it's really not changed. Okay, so what that gives me then is I have negative 1/2 times the integral, and I have in the denominator cosine of 2t plus 3 is being raised to the second power. So that's going to be substituted with u to the second power. Okay, and then in the numerator we have exactly our du. All right, now we don't like having the power in the denominator to apply our rule, so let's think of this as the integral of u to the negative 2 du. And this is going to now apply the power rule, leave the negative 1/2 out front. The integral of u to the negative 1/2, we're going to go u to the negative 1 over negative 1, adding 1 to the exponent. And then this is an indefinite integral, no bounds, so we do have to put the plus c. All right, now moving the u to the negative 1 to the denominator and multiplying the negative times negative gives you a positive. You have 1 over 2u plus c, but we didn't have u's to start with, so our answer needs to be in terms of t's. So remember, u was actually cosine of 2t plus 3. So that's going to be 1 over 2 times the cosine of 2t plus 3 plus c. Okay, so that's a few problems from our last quiz, the one to help you prepare for the test. So if you have any other questions, don't hesitate to contact me. You can email me, you can Skype me. You can find me via Skype by looking up the email qhearn.broward.edu@gmail.com. Okay, and we can text back and forth or using that, or we can talk, or we can even do video chats. So that's my Skype. That's for my students. Okay, thanks very much, guys. I look forward to hearing from you.